we had all these different groups in different buildings in different parts of Norman, and some of the people were working on the same exact projects on either side, but they just weren't really collaborating with each other. So the former president of OU, David Bourne, was working with the OU and the NOAA partners to conceptualize the idea of the National Weather Center, bringing everybody together into a shared collaborative space. So their task was to bring together the state and federal appropriations for the facility to get that going. It wasn't really accelerating very quickly until we had the May 3rd, 99 tornado outbreak here in Oklahoma. And on that day we had 61 tornadoes, which is usually the yearly average for tornadoes in Oklahoma for a calendar year. And the fastest wind speeds ever recorded on planet Earth happened on that day and more. It was over 302 mile per hour EF5 that went through more. So 5 days after the event, when former President Clinton visited to view all the damage and more, while he was giving his speech in front of a large pile of debris in Moore, he uttered the words National Weather Center as a place to bring all of these folks together to do the severe weather research, and everybody was like, that's such a great name for this building.
The movie Twister actually brought in a lot of new meteorology students and some National Geographic programs and stuff. So there was a need probably starting from, throughout the 90s. There was I guess everyone recognized the need for a single building to house the various meteorological organizations in Norman. And there was even a plan for several years, but no money.
Professional atmosphere. You kind of got two things going on. You've got the scientific, professional part of you that's, you come to work that morning, you kind of have a sense of the kinds of things that might happen or could happen. You wish they wouldn't. And then you come in with a purpose and a mission, and we have a job to do. Our job is to provide information to people, give them as much advance notice as we can about bad things that could happen. So you have that part of you, but then you're also a person. So then you also have the sense of anxiety, dread that I think a lot of people around here have. We're scientists, and most of us live and work in Oklahoma because we're interested in tornadoes and severe weather, but nobody wants anything bad to happen to anyone. So you do have that part of you, and specifically for me, I remember especially the morning of May 20th of 2013, just waking up with this sense of dread that we had hoped that maybe the weather conditions would change a little bit overnight and we wouldn't be in the prime spot that we ended up being in for tornadoes that day. But then you wake up in the morning and you're like, well, nothing changed. Something bad is going to happen somewhere. You just have that sense of dread, and it's not helplessness. You can't stop the storms. That's our mission here, is to work as hard as we can to make people ready for them. So you kind of deal with that part of yourself, I guess, on a day like that. But
not have that early activity, then that affects, its afternoon forecast. So you got to pick, this model correctly has all this cold outflow air from these storms, and that'll affect the forecast later. So I like that model better in terms of where it's going, the unstable air, and then wind profiles.
Pyranometer kind of up on that back side, there's a little disc up there, and that does measure solar radiation. It's useful for different aspects, but for a lot of those sorts of things, if we're looking for error sources, for example, we tend to have more errors when we're in direct sunlight. A lot of our kind of observations are designed around the idea that we're going to be operating in and out of severe weather. A lot of it's usually cloudy. So having the ability to tell when we're in heavy clouds or not is really useful. There's a GPS unit up there on the top, kind of in that middle where that Garmin puck is. That gives us vehicle heading and vehicle direction and vehicle speed when we're moving. And the idea is that if we know what the vehicle heading and speed is, and we know what the wind direction and wind speed is relative to the car, we can use those two vectors, we can actually back out what the ambient wind speed and wind direction is. And that's why we can drive the winds while we're on. It's a lot of trig and math involved, but it works.